Okay, sorry. I did not mean to split this into a third video, but there was commotion, so I am. Alright, so the last problem has us use that force equation. It's actually a little bit easier than the one I just did. Okay, so the last problem says a horizontal force of 280 newtons is exerted on a 2 kilogram discus as it is rotated uniformly in a horizontal circle of radius 1 meter. Calculate the speed. So we've got the mass. We have a 2 kilogram discus. They tell us that the force that's making this happen is 280 newtons. And we know that the radius is 1 meter. So F, sum of all forces, is equal to mv squared over r. Anytime they give us a force, we think we're going to have to use this equation. And so in this particular problem, they're asking us to find v. We want to know the speed at which this thing is rotating. So this equation is a better choice than v is 2 pi r over t, because I have no idea what the period of this traveling thing is. And so if I take a look at this, I'm just going to solve for v. So I'm going to multiply both sides by r. So r, you can drop the sigma if you want. So you say r times f is equal to m times v squared. We're going to divide both sides by m, and that leaves us with v squared. So v is equal to the square root, sorry, let me drop that square, of r times f over m. So it's the square root of 1 meter times 280 newtons divided by m, which is 2 kilograms. So this is going to be a little bit less than 12. It's about 12, a little bit less if you put that into your calculator. So a pretty simple problem, right? So the first homework set that I'm going to have you work on until we meet virtually again has all the problems. Just use a combination of these 3 equations. Now there are 2 of them that I think are a little bit more challenging. One involves something that is spinning vertically. So again, that's something that's spinning like this, where like my hand is the center, right? And if you do this, like pick something up in your house, because you have plenty of free time right now. So pick something up at your house and spin it. And if you spin it in a vertical circle like this, you'll feel the tension change. You'll feel that it's more tense towards the bottom and it's coming up into the swing towards the top, and you'll feel the tension decrease at the top and continue to be smaller as it comes down and then increase again. So there's one problem that has you look at the tension changing, and they even draw the free body diagram for you. So I forget if this is number 8. You'll see it when you get into it. But you have something that's spinning in a circle like this, and they draw it at the top and they draw it at the bottom. And at the bottom they say you have mg down and they have tension up. This is the center of the circle. And at the top you have mg down and tension down. And they ask you to, I think, find tension, right? And they give you some information that I'm not giving to you right now. But I wanted to point out here, if you look at this, sorry, I'm going to move the camera in the setup. At the bottom, when you put the numbers in, and I'll give you the keys like in the good old days, like I used to, so you'll see this eventually. But at the bottom, the acceleration is straight up, and you need to know that when you're solving for the bottom. And at the top, the acceleration would be towards the center, so straight down, and that changes the direction of things. So that's a hint for the one homework problem. So you'll see that one when you get into it. It'll be this picture, and just keep that in your mind when you're trying to solve it. The other problem that might be a little bit more challenging is about a roller coaster. And all I will say is this, and then we'll probably end up discussing it, and I'll solve it with you. I want you to try it first when we check in next Monday. But the roller coaster problem is like a 2-liner. It is mathematically really, really simple. So if you are struggling with it, keep that in mind. It's a very, very simple problem. And when you are beginning to fall out of a roller coaster, you would also lose your normal force. That would be my hint to you about that one. So otherwise, I will check in. Well, we'll check in live, so I'll see if you have any questions. And I'll be thinking of you and have new lectures for you on Monday. Bye.